Yeah, I'm sorry, everyone. Let's start off. Great. So last thing that we're doing was this positions and everything. Let's do one more question before going ahead. We have two mirrors here, one convex and concave, radius r, radius r. Let this be M1 and let this be M2. At the center, we have the object. This distance is r and this distance is also r. It's at the midpoint. Find the position of the images after two reflections. What in by two reflections? So first the light rays will hit M1, they'll form an image here. This light rays will fall here, then they will form an image here. So I want that one. You're getting what is the meaning of two reflections? So you need to find the image in M1, then find the image of that in M2. Second case, the light rays will fall on M2. That is the first reflection. Then they'll hit M1 and then bounce here. That will be the second image. Are you getting what I'm asking? So after two reflections, find the position of the images. Get this? It's just brute force solving. Nothing much to think. There are two answers, right? You are way poor. See the first thing? Let's do M1, then M2. So for M1, that's a concave mirror. You can clearly see the object is at the center only, isn't it? Radius is R, the center is also at R. This O is the center only. That means after first reflection, the light rays will go here and they'll come back to the center. So the first image will form at the center. So this I1 will act as an object for the second mirror M2. This is I1, this is distance R. The left side is positive. The direction of lattice is taken as positive. So U will be minus R. The focal length is R by 2. So if you put it in the formula, 1 by V plus 1 by minus R is equal to 2 by R. We get V is equal to R by 3. This is your first image. R by 3 from M2. Is this making sense? So first you find image in M1, then find the image of that in M2. That is the meaning of two reflections, isn't it? Now when you do the same thing for this thing, M2, then M1, luckily we have already finished the first part. So first you have to find the image in M2. So O is the object, this distance is R. This is the same thing we just now calculated. So this image will be I1 here, this will be R by 3. So this I1 will act like an object for the concave mirror. Now be careful that distances are always measured from the pole of the mirror, isn't it? So if this is I1, the distance must be this one, which is R by 3 plus the distance between the mirrors is 2R. 7R by 3. The direction of light rays is positive, so right is positive. The U is equal to minus 7R by 3. Focal length is equal to minus R by 2. So 1 by V plus minus 3 by 7R minus 2 by R. How much is this? V is equal to minus 7R by 11. That means the light rays from here will hit this mirror and they'll meet here. This is your I2. Is this clear, everyone? Right, Kush. Yeah, others see where it messed up. F is negative. See, for a concave mirror, F will be always negative. For convex mirror, F will be positive. That is the advantage of the sign convention. In our sign convention, right, concave mirror will always have focal length negative. But if you use the Cartesian coordinate, that will keep changing. That's the reason I don't like the Cartesian coordinate method. I just stick to this thing. Direction of light ray is always positive. Meaning, if you put a concave mirror like this, or you put a concave mirror like this, the radius of curvature, if you see it, is always negative. All clear with this? Like, there's nothing to think here. It is just that brute force. You just have to apply the formula twice and you'll get the answer. This is one thing in ray optics that you'll notice. You will have a lot of things. You just have to apply the formulas and sign convention. You'll get the answers. All got this? Next thing. This is again mostly theoretical thing. Suppose if I ask you to draw a graph for a concave mirror. So 1 by V plus 1 by U is 1 by F. This is a rectangular hyperbola. Let's say this is V, this is U. So if U is positive, means it is a virtual object. So in a concave mirror, U is positive, meaning it's a virtual object. V is positive, meaning it's a virtual image. So you have to do with the sign convention. U is negative is a real object. Can you plot this graph? How will the graph look like? Try, I'll give you a minute. You have to draw a graph of V versus U graph. So right is positive, left is negative. How will this graph look like? Think. Always, see, whenever you have to draw graphs, right, it is always easy to eliminate. Think of like this. When object is at infinity, where is the image? At focus. That means if u is minus infinity, then v is minus f. Isn't it? Image is also on the left-hand side. So, seeing from that perspective, let's put some points here. This is minus f. When object is at the center, where is the image? At center. That is 2f. Now see, so when u is infinity, v is minus f. So the graph starts like this. And when u is minus 2f, that is at the center, v is also f. So the image should, this graph should pass through this curve. This point is the center where both are 2f and 2f. And if you continue the graph, this will start going to, so as the object gets closer and closer to the focus, then v ka value will get minus infinity, isn't it? So as this u ka value is getting closer to minus f, v ka value will go to infinity. And once you cross the f ka value, image becomes virtual. So it will come from plus infinity. If you are at the pole, image is also at the pole. And as the object goes to plus infinity, the image comes to focus again. This is how the graph looks, everyone. So you should have a rough idea how it looks. Got this? And like I keep saying, it is always easier to eliminate the option than actually drawing a graph. So if you're looking in the exam, you need to check a graph where it should pass through the center and at u infinity f, v ka value is f. And when you're at the pole, image is also at the pole, so it should pass through the center. So if you know few data points like this, you can eliminate the graphs. What about a convex mirror? How will that look like? Try, I'll give you a minute for this. Again, same thing. Think about it. When object is at infinity, where is the image? At plus f, isn't it? In a convex mirror, image is at plus f. As you get closer and closer to the pole, image also becomes at f. So this is f. So when u is minus infinity, this thing will get closer to this thing. As you get closer to the pole, this will be like this. There, this is how the graph looks. So once you cross this thing, it becomes virtual. Clear with this? So as the object is coming from minus infinity towards the pole, the image will get closer and closer to the pole. So image will travel from v ka value will go from plus f to 0, isn't it? Once you cross this point, the images become virtual. Meaning virtual image means what? Virtual object means this. The light rays are trying to convert somewhere here. So this is called a virtual object, but they meet somewhere here. So the point where the light rays were supposed to meet, for example, see, let's say due to a lens or something, we'll see some problems like that later on. Let's say light rays are coming like this and they're supposed to meet here. But what you did, you went and kept a mirror here. What will happen? So these light rays were supposed to meet at O here, but because of this mirror, they will bounce off here. So this point O is called a virtual object. It is not real. The light rays were supposed to meet there, but you blocked it with a mirror. That's why we call it a virtual object. Are you getting it? So that is the meaning of a virtual object. Anyways, we'll see that thing. Clear? In this thing, the easiest graph, right, will be if they ask you a graph between 1 by V plus 1 by U. So 1 by V plus 1 by U is 1 by F. This looks like Y is equal to Y plus X is equal to constant. For a concave mirror, for real thing, V and U both are negative. So this will be in the third quadrant. Convex, it looks like this. Be careful with the sign conventions. Clear?
So,
Yeah.
sir, could you explain once how convex mirror is forming a real image?
If the light rays are going and meeting at this thing, so if the light rays are supposed to meet here on the right hand side, then the image is real. This point is suppose where the light rays are supposed to come and hit, but the mirror is blocking it. So they will come and meet here. So they are actually meeting. It's a real image and it's a virtual object.
Okay, sir. So it's
The
not
meaning
necessary.
of virtual object is it's not an object. Think of like this. It is a virtual object is a point where the light rays would have met, but this mirror went and blocked it.
Okay, got it.
That way, think of like that. It's nothing. There's nothing actually there. Like I said, let's say there is a lens here. The light rays were supposed to come. The lens is supposed to form an image here. But you kept a mirror in the middle. So the light rays have to hit the mirror and bounce somewhere. So the mirror will think this was an object, and for that, this would be an image.
Yes.
Actually, it comes from principle of reversibility. Remember, I told you if you take an object and put it in the place of an image, then the image will form in the place of an object. Both can be interchanged. But the meaning of virtual object means it's not a real object. It was supposed to be there, but the mirror is blocking it. Think of like that. You'll see. Next thing, these are important questions. Let's say we have a mirror here, R is 20 centimeters. Let's say object is at a certain height, 2 centimeters. And let's say this is 30 centimeters. Find the position of the image. Now remember that formulas we derived are valid only when the object is on the principal axis. So let me show you how to do this thing. So if the object is not on the principal axis, this is how you do. Step 1, drop a perpendicular from the object onto the principal axis. Let's call this thing O dash, the foot of the perpendicular. Now O dash is on the principal axis. That means I can use the formula for O dash. Step 2, so treat O dash as an object. Find the image of O dash. That because the formulas are valid for O dash. Right. Step 3. Now the image should lie, the actual image lies on a line perpendicular to the principal axis and passing through O dash. So basically you can use the formula magnification minus V by U is equal to height of the image by height of the object. So let me show you this. Step one, drop the foot of the perpendicular onto the principal axis. So this point will be O dash. So O dash is on the principal axis, so I can use the formula. So for O dash, 1 by V, U ka value is minus 30. Here radius is negative, so R by 2, so 1 by minus 10. I will get V is equal to minus 15 centimeters. Then use the magnification minus V by U. This is minus of minus 15 by minus 30. This is minus half. So height of the image by height of the object is minus half. Height of the object is 2 centimeters, so height of the image is minus 1 centimeter. So the meaning of this is the O dash ka image will be I dash that will form at a distance of 15 centimeters. So your image should lie somewhere on this line, and you're getting height of the image is minus 1 centimeters. Minus indicates it is below the principal axis. So your image is here, I at a distance of 1 centimeter. Is that making sense? How to do area? So the thing is like this, if a person is standing here, if you can find the image of the foot, shouldn't the head also be on the, somewhere at that place only then? That is the logic there. Is everyone clear how to do these questions when the object is not on the principal axis? Clear? Now you guys try this. We have a concave mirror, radius is 20 centimeter. Take it as R. We have an object which is going on a circle. With constant speed u. The radius of the circle is a. This distance is 2r. So if the object is going on a circle, image also will be moving. Find the speed and the acceleration of the image. Take it as V naught because U are already using for image distance, object distance. So particle is going in a circle with speed u. Are you getting how is this circle? Do you remember electrostatics we did, na? Field on an axial line due to a ring. So the circle is like that. Circle is not like this. The circle is perpendicular to the plane. Find speed and acceleration of the image. Any answers? Let's see. V by 5, acceleration u square by 2, 9v, near. Speed will be less actually. So here the object is at a height of a. Drop the perpendicular. So the image will be, so for O dash when you do, it is 1 by V plus 1 by minus 2R is equal to 2 by R. We get V is equal to 2R by 5. So magnification will be minus V by U, which will be 2 by 5. That means your image will be somewhere here and it will be going in a circle whose radius will be 2a by 5, isn't it? It will be going in a smaller circle. 2a by 5 or 1 by 5? 1 by 5. It will be going in a smaller circle of radius a by 5. So what does the object and image have same? What do they have same? Same omega, isn't it? They take same time to complete one revolution. So the object and the image have same angular velocity or same time period. They don't have same speeds because the time taken for one revolution for an object will be also one revolution for the image. So therefore, omega will be v naught by a for the object. For image, it will be v image a by 5. Therefore, velocity of the image will be v naught by 5. And what is acceleration? Since it is going in a circle, there will be a centripetal acceleration, which is nothing but omega square radius, which is a by 5. So v naught square by a square a by 5. That is the acceleration of the image, everyone. Is that clear, everyone? That is the main thing there. The time period will be same for both of them. The questions will be like this. No one will ask you find the height of the image. You mixed up a little circular motion here. All got this? We have a convex mirror here. Let's say there are 4 points here, A, B, C, and D. These distances are, this distance is also R. This is A and this is also A. We take A is much less than R so that the rays will be paraxial. So this ABCD will form 4 images A dash, B dash, C dash. So if you join 4 of them, you'll get a quadrilateral. Find area of the quadrilateral. Formed by images of A, B, C, D. So there are 4 points. These 4 points will create four images. If you join all these 4 images, you will get a quadrilateral. Find the area of that quadrilateral. Get this. I'll give you 2 minutes. Any answers? Nere Purvaja. One more minute. Let's see. Hey, Arush. Right, Saish. Right, Ishana. Right, Aditya. See. So if you take the image for A, you just need to do for two of them. So drop the perpendicular, you will get A dash, drop the perpendicular, you will get B dash. So for A dash, it is 1 by V and the U will be minus R and the focal length is 2 by R. So V is R by 3 and the magnification is 1 by 3. For B dash, it's 1 by V plus 1 by minus 2R is 2 by R. So V is 2R by 5 and the magnification is 1 by 5. That means this A ka image will be somewhere here, A dash, and B ka image will be somewhere here, A and B. This height will be similarly just below A, you have D here. So D also will be somewhere here. C also will be somewhere here. This distance is R by 3. This distance is 2R by 5. A ka magnification is 1 by 3. So this is A by 3. This is A by 3. This magnification, I drew it wrong. So B will be like this, C will be this. They'll be small actually. So this will be A by 5 and A by 5. So when you join them, what you get is actually a trapezium. Hope you noticed that you'll get a trapezium. Where this is 2A by 5, this is 2A by 3, and this distance will be R by 15. Area of a trapezium is half into sum of the parallel sets with this. You will get 8AR by 225. Check. Got this? It forms a trapezium actually if you join the 4 points. Tell me one thing, instead of putting 4 points, you will see the reason why I kept 4 points and not some cube. This itself could be a decent mains level question. Suppose if you take a convex mirror and in front of it, if you put a square, can you draw the image of the square? That will be a decent mains level question. Draw the image of the square. So the 4 options will look like this. You will get a trapezium, you will get a small square, you will get something like this, you will get something like this, you will get something like this, you will get something like this. ऐसा 4 options होगा, 6 options I give. And they'll ask you to get the right one. Now you draw and see. Tell me how it looks. Think I'll give 30 seconds. Let me ask you this way. Do you guys remember this question we did? If an object is going in a straight line, how will the image look like? Image looks like this, isn't it? Do you guys remember that? Last time we did that. So how will the image look like? The image will look something of this sort. This is not a trapezium. This parts will be curved like this. The biggest confusion comes, people know it will be a curve. The confusion will be between these two. And if you remember last time we did, if the object right is coming, so that means if this is a long rectangle, how will the image look like? The image will start at the focus and it will look like this, isn't it? Making sense? So if you have a square, the image looks like this. This will be B, this will be B, this will be D, this will be A, and this will be C. Got this, everyone? A decent theoretical question. So this is the reason I gave you 4 points. Because if I give you a square and ask you find the area, you will die. We can't find the equation of that curve. It becomes really messy. So if it is only 4 points, it forms a quadrilateral. It becomes easy to see. All clear with the stuff? So if the object is not on the principal axis, this is how you handle them. Now, these next questions are the important ones. Let's say we have a concave mirror. 20 centimeters, mirror is at rest. We have an object here which is going with a speed of 2 centimeters per second. Now, what happens if the object starts going like this? And this is 30 centimeters. Find the velocity of the image. Try. Think for a minute, then I'll show you how to proceed with this. I'll show you the concept, but you try to see how to do this. Plane mirrors are easy. Curved mirrors, they won't go actually in a uniform thing. Find the velocity of the image with respect to the ground at this instant. Let me help you see. How do we start this? Listen to this thing. There is a small catch here. You should know this derivation. If something messes up in the question, this is how you will always get back to. And this is the same technique we'll use in lenses also. So we know the formula 1 by v plus 1 by u is 1 by f. Differentiate both sides with respect to time. This will be 1 by v square dv by dt minus 1 by u square du by dt minus 1 by f square df by dt. In our case, the focal length is constant. So this term will be 0. But remember, later on, I'll show you in lenses, I'll give you a case where f is not constant. So if you blindly mug up the formulas without understanding when it works, you will have a problem. Since f is constant, so if f is also a variable, then this will change. So then the formula becomes dv by dt. Till here, most people remember this formula, but they actually don't know what they're dealing with. Now you have to be careful here. What is exactly u and v? What is u? Image object distance. Measured from where? U is an object distance measured with respect to the mirror, isn't it? That means u is the distance between the object and the pole of the mirror. What is v? V is the image distance with respect to the mirror. That means if you differentiate du by dt, you won't get velocity of the object in the ground frame. You'll get velocity of the object with respect to the mirror. Are you getting this? So du by dt and dv by dt are relative velocities. They are not the actual velocities in the ground frame. In our problem, the mirror is not moving, so you're safe. If the mirror moves, you will have an issue. You have to take relative velocities. So u and v are measured with respect to the pole. So these are the velocities with respect to the pole. So this formula is actually dv by dt is velocity of the image with respect to the mirror minus v square by u square. This is velocity of object with respect to the mirror. So let me write that full thing actually. This is velocity of image with respect to mirror. This is velocity of object with respect to mirror. V by u is magnification. So I can write this as Im is equal to magnification square, velocity of object with respect to mirror. And remember, these formulas are valid only if f is constant. And what about the sign convention? Velocities in the direction of incident ray are taken as positive. If the object and the image are going in the direction of incident rays, it is positive. If they're going opposite, it is negative. So there, so you just need to find v ka value and you can just put it in the formula, you'll get the answers. Velocities in the direction of incident ray are positive. Now, coming back to this question. First find u ka value. So 1 by v plus 1 by minus 30. The focal length is minus 10. So we get v is equal to minus 15 centimeters. Since here the velocity of the mirror is at rest, so velocity of image with respect to the mirror is minus v square by u square, velocity of object with respect to the mirror. This will become the ground only. This will be 15 square by 30 square, and the object is going in the direction of light rays, so plus 2. This will be minus half centimeter per second. That means you have an image at 15 centimeters, and minus indicates it is going opposite to the light rays with a speed of half centimeter per second. Is this clear, everyone? Yeah, most of you did get it. All clear the process? So this is important. So if your focal length is changing, you have to go back to the derivation. You can't use this formula. Any doubts on this? Clear, na? Pratik, Arush, Aditya, Devansh, Vivan, Kush. Now you guys try this. Let's say we have a convex mirror, radius is 20 centimeters. The mirror itself is moving with the speed of 5 centimeters per second. Object is going with the speed of 10 centimeters per second. And let's say this distance is 40 centimeters. Now find the velocity of the image with respect to the ground. So that formula actually gives you only relative velocities. Hmm. 20 by 3, 9.344, 20 by 3, 22.4, 28 by 5. See, एक number नहीं आया जिससे you have 220 by 3. That is the only thing. First find the position of the image. 1 by V, 1 by U is minus 40. Focal length is 10. So V is equal to 8 centimeters. Then the formula gives you velocity of the image with respect to the mirror is minus V square by U square, velocity of object with respect to the mirror. So stop the mirror. So this will be 8 square, 40 square. Mirror thinks object is coming with 15 centimeters per second. Agreed? So if you stop the mirror, mirror will think object is coming with 15. So 8 by 40, that is 1 by 5 square, that is minus 15 by 25. That turns out to be minus 3 by 5 centimeters per second. But this is not the answer. You want velocity of the image with respect to the ground, which is nothing but velocity of the image with respect to the mirror plus velocity of the mirror with respect to the ground. It's like the image is going inside the mirror with something and the mirror itself is moving. It's like you walking on an escalator, isn't it? So this is minus 3 by 5 and the image is also going back. So minus 5, minus 28 by 5 centimeter per second. Yeah, someone got this. You got it. Ansh, yeah. 9.34, maybe that could be the thing. Someone got 28 by 5. Who's think Aditya 9.34. Yeah, that is there. Vivan got it. There. Clear with this? That's what I'm saying. So be careful. That formula is actually with respect to the mirror. The people who don't realize this, they'll just blindly put it and they'll get some weird answer. Let's see one more. So these questions, these are still okay. This question becomes tough when you do something like this.
So in the previous question, rate of change of focal length, can we take it as the speed of mirror?
Why is the focal length changing?
like वो जब differentiate करता है originally तो
F
उसको
तो
zero
zero है,
लाना
F तो constant है ना.
एक बट अगर मिरर जो मूव कर रहा है उसको लाइक
चलो
ऐसा
मिरर मूव कर रहे हैं, सुनो मिरर मूव कर रहे हैं, सेंटर क्या कर रहा है?
मूव
If the mirror is here, सेंटर भी यहाँ पे होगा, रेडियस चेंज नहीं होगा ना गॉड. अगर तुझे फोकल लेंथ चेंज करना है ना, then I should do something like this. I should say this radius is equal to 1 plus t. मतलब this mirror is becoming bigger and bigger. I should mess up the radius. Moving the mirror doesn't change the radius. So 20 centimeters. We'll see. Focal length ka changing in lenses. Mirror at rest. This would be a good question. The object is not on the principal axis. It is going above the principal axis. Now what? Now find the velocity of the image. I can move the mirror also here, but yeah, ठीक है. The object is going above the principal axis. Find the velocity of the image. This would be an advanced question. Try. I'll give 2-3 minutes. Can you tell me how will this image even move actually? If you remember, the image is going like this, isn't it? So this will have two components. It will have a Vx, it will have a Vy. Now, luckily, the Vx part will be same as the previous one. When you differentiate that formula, what you are getting, so this is O. I kept the numbers same. We get V is equal to 8 centimeters. So when you apply this formula, velocity of the image will be I dash comma m is equal to minus v square by u square velocity of object dash m. So this actually gives you, so this is minus 1 by 25 and this is 2. This is minus 2 by 25 centimeter per second. So this gives you component along the principal axis. So this gives you the x component. So this is not a complete answer. So there is a y component also. How will you figure out that? So this is still one part of the problem. So if the mirror moves also, nothing much will happen. Let's say the mirror is moving with 1 and this would have been 3, and then again you win the ground frame. So that part all will be same. How will you find the y component? Y component 2 by 25 near here plus we have 0.4. Why are you giving in decimals? Just put it in fractions, na God. You're using calculator, yeah? Put it in fractions. Who will calculate it for you every time? I know you're good in maths. We all agree unanimously. So just put it in fractions. Your teacher is not really that great in maths. अभी मैं आंसर चेक ही करूँ सब डेसिमल्स कैलकुलेट कर रहा हूँ 1 by 125 एक्चुअली मुझे आंसर याद नहीं है but one thing you will not get a decent one, you'll get some triple digit ka something. See, this is how you do. The only one who gives you something in the vertical direction is magnification. So magnification is minus v by u, which is height of the image by height of the object. So height of the image will be minus h naught v by u. Right? So if I differentiate this, what do I get? I get the vertical component. So the rate of change of height of the image is nothing but this. So this will be minus h naught v by u. You can use chain rule 1 by u, product rule dv by dt plus v into minus 1 by u square du by dt. I am just using UV rule for this. H naught will be 2 centimeter. This is 1 by u. U is minus 40 centimeters. dv by dt is this guy. Minus 2 by 25. Be careful. This is velocity of the image with respect to the mirror. This guy is velocity of O dash with respect to the mirror. And V ka value is 8. U square is 40 square and du by dt is plus 2. How much is this? Send this 2 inside. This will be 1 by 250. That will be 4, 40, 40, 10, 5, 1 by 50. 2, 2, that will become 4. 8 into 4 by 40 square. 1 by 50. And this will become plus. This will remain minus. I hope I'm doing the calculations right. This will be how much? Now this thing is having good number only, I guess. Multiply 5 there. That will be 4 by 250. Or 2 by 125 centimeter per second. Check. Right, Puruja. So how does the final thing look like? You're getting plus, means it is actually going up. So the final answer, at a distance of 8 centimeters, at a height of, magnification is how much? 8 by 40, 1 by 5. So at a height of 2 by 5 centimeter, you have your object whose vertical component is 2 by 125 centimeter per second. It is going left side with 2 by 25. That will be a final answer, everyone. So if the object is not on the principal axis, you will also get a y component. It becomes a little lengthy, but yeah, this is the process. You have to take the magnification and differentiate. You know what can be more messy? Instead of this thing going in a straight line, if it is going at an angle, can tell me what will change? If this particle is going at an angle theta, then what will change in this thing? H naught also will change, na? So d h naught by dt will be u sine theta, the vertical component. So all three will be variables. So differentiation will become much bigger. But got it? So it becomes mathematically more complex, but conceptually it is still the same story. Differentiate this guy to get the Vy component. Is that clear, everyone? All got this? Take a break. Come back by 9:40. Any doubt so far? Okay, come back in 5 minutes. Let's say this time the object is going vertically up, perpendicular to the principal axis. There, let's get this. So this time object is going perpendicular to the principal axis. This will be a decent question. This is what I was saying. If you just mug up the formula without understanding what you're doing, you will get stuck like this. I'll just change something and you'll not understand what is happening. This is easy. Yeah, there'll be no horizontal component, right? If you see horizontally, there is no motion. So du by dt ka term is 0 here. Because no matter how much it will travel, the foot of the perpendicular will be always O dash only. So there is no horizontal component. V ka value is 8, U ka value is minus 40. So when you take the magnification, minus V by U is equal to height of the image by height of the object. We get height of this thing is minus V by U, which is constant, into H naught. So Vy will be dhi by dt. This will be minus 1 by 5 dh naught by dt. Dh naught by dt is 2 centimeter per second. Minus actually goes off. Easy. This thing actually looks scary, perpendicular and all, but it's actually easy to do. The tougher one would have been this, 2 centimeter per second at an angle theta. Then du by dt also will change. You'll have 2 cos theta and 2 sin theta. Then it would have been a little more complex, but I hope you got this. Then the only headache would be differentiating all these 3 variables. That would be the headache. You have to use the product rule for u, v, w. All clear with this thing. So you know how to handle if the mirror moves, you know what happens if that moves at an angle, if it moves at a certain height. These are all the things. So these are one important set of questions. I kept them all together. So that is one thing. Next thing, Newton's formula. This is another a decent result. We normally measure the distances from the pole. What if you measure the distances from the focus? Quite an important result. Definitely mark it up. So let's say this is your focus, this is your image, this is your object. Let this distance be x. Let this distance be y, and this is your focal length f. Same thing you can even do with this thing, the convex also. In convex, this will be the focus, this will be I, this will be object, this will be y, and this will be x. Same thing, you can use the sign convention and get it. I'll use it for the concave. For the concave, u will be minus of x plus f. V will be minus of y plus f. So when I substitute the formula, I'll get 1 by v minus y by f minus x plus f. And remember, even the focal length is negative for concave. Minus f. So it is f backward. Minus goes off, cross multiply. You'll get x plus f plus y plus f into f is equal to y plus f into x plus f. Simplify this, you will end up with a good answer. Xy is equal to f square. There, it's a pretty good result. There was a question like this once. The object and the image distance from the focus are something like 9 centimeter and 3 centimeter. Find the focal length. Now, people who know the formula, they just substitute and finish it off. People who didn't know, they derived it. Matlab, you can always put it in, then you can solve it. Quite a useful result. The same result also will be there for lenses also. So there x and y are distances from the focuses. There are 2 focuses in a lens, so we will see that. But the same formula is valid there. And this formula also tells you one thing. If you see, xy must be a positive number. That means x and y must be both on the same side of the focus. Meaning, look at here, O and I are on the left side of the focus. You're also on the left side of the focus. Means you'll never get a situation where the focal length f will not be between object and image. You'll never get a situation where focus will be between object and image. There, just a formula there. Yeah, it's a good one. Clear with this. There, that's a bit about the mirror. So we have done plane mirrors, then we have seen spherical mirrors, we have seen graphs, mirrors moving, all this stuff. So all this thing is a reflection. The next part is refraction. Now in refraction, there are two parts: refraction on a plane surface and a curved surface. In curved surface, you also get lenses and everything. Both are important. So plane surface, especially the apparent depth and all that stuff we have. So we will see the plane surface first. So first of all, what is refraction? So the bending of light rays, that's a phenomena where the light rays bend at the interface of the two mediums. So before going ahead, we need to define something called mu, refractive index. So a refractive index, the dimensionless quantity, it is simply the ratio of speed of light in vacuum by speed of light in medium. So this is C vacuum by C medium. So basically light travels fastest in the vacuum and it actually slows down in the mediums. The speed of light in a medium is given by C vacuum by mu. This thing again we'll discuss a bit in waves also, but there's a thing here. So whenever a light goes from one medium to another medium, frequency doesn't change. Light has three properties: frequencies, speed and wavelength. So frequency is like, the number of waves per second that does not change when you go from one medium to another medium. Frequency does not change with medium. So there was a question like this. How does the color of a light change from medium to medium? Now understand, color depends on frequency. Since the frequency doesn't change, the color doesn't change. That means if you put a red bulb under the water, when you come out of the water, it still looks red only. It doesn't change color. That was a CT question. So the medium wavelength does get messed up. So it becomes lambda vacuum by mu. So why is this light ray exactly bending at the interface? Now, this is something we did discuss before also. I think long back I told you once. You guys remember how does an aeroplane take a turn? We had this discussion once. If you have an aeroplane and you want to take a sharp right turn, not gently, if you use your wing cuff flaps, you can gently make it a turn. But let's say you want a sharp right turn. What do you do actually to the plane to make it take a turn? Now, don't say like you will just rotate the steering wheel and it will rotate. So when you do something like that, physically something happens to the plane and that's why it makes a turn. So what is it that happens to the plane? Tilt and pull up. Kya tilt and pull up? Do an announcement, na? All passengers please go to the right side so that we will take a right turn. That doesn't work actually. If all passengers go to the right turn, maximum what will happen is the plane will become like this, but it will still continue to go in a straight line. You guys remember? Don't remember this? I thought we had leaned the plane. That doesn't work. Right? If you just lean it, it'll just stop the engine only. Arre Vihan, gira de rahe. Because of people like you only, the plane crashed in Gujarat. Stop the engine only. You should never become a pilot. See, so what we do here, you increase the thrust of one engine compared to the other. So when you increase the thrust of one engine, what will happen? So left side of the plane will try to go faster compared to the other plane. Now you tell me, how can, if you have a rod, how can the 2 points of the rod travel different distances but still be together? If they go in concentric circles, isn't it? The plane still has to remain intact, but they have to travel different distances. So the left wing has to travel more and the right wing has to travel less. So you increase the thrust of one engine compared to the other. The plane will start taking a turn because the left side is traveling more. Once you got the desired angle, then make the thrust equal, it will go in a straight line. Is this making sense? And this is the whole concept in everything. Any physical system that you take, and when it is taking a turn, this is the idea. If you have your car and you want your car to take a turn, something similar happens. These wheels actually rotate faster. So these wheels will cover more distance compared to this, you take a turn. Or if you ever been in NCC marching, anyone has done this marching in school or ever seen an NCC thing? Next time observe that when this NCC parade is going on, and when they say, platoon, right turn, you'll observe this person in this corner, right? He's at the same place. He's doing left, right, left, right, left, right at the same place. He's just lifting his leg and putting down at the same place. And during that time, this person will come till here. This person will come till here. When both become in a line, then they start going again. So basically, when the platoon right turn, they say this part of the crowd actually slows down and this part actually goes faster. Next time, think about it. When you're walking and suddenly someone comes in front of you, what do you do? And you take a right turn, what do? You literally stop on your right leg. You use your right leg like a hinge and you swing about the right leg, isn't it? So even you do that. When you're walking and taking a turn, you do that. If you're taking a left turn, you slow down your left side and your right side goes faster. And if you're taking a sharp right turn, what you do? You literally stop your left leg. You use it like a hinge. And about that leg, the whole body rotates. So this is a principle actually. Any physical system wants to take a turn, you create a differential in velocities. Make sense? This is a theme there. So something similar happens with our light also. So when you take an interface here, let's say this is mu1, this is mu2, and this is mu1 is greater than mu2. So this is going from mu1 is denser. This is rarer. So here, what is happening? So when the light beam, let's say, comes at an angle theta. Now, what is happening when you send the light ray at an angle, the entire light ray will not enter into the medium at the same time, isn't it? A part of the light ray is in one medium and another part of the light ray is in another medium. So if I take this point as A and if I take this point as B, so by the time B travels from here to the interface, let's call it B dash. Now, because it's a rarer medium, A will travel little more. Agreed? Light travels slower in a denser medium and faster in a rarer medium. So A dash will reach here. So this becomes a new light beam. And if you notice here, initially the light was coming like this. Now this whole beam got shifted like this. Isn't that what happens when a light ray comes from denser to rarer medium? It goes away from the normal. You're getting it? So something similar happened here also. When you send a light ray at an angle, you're creating a differential. A part of the light ray is going faster. One part of it is going slower. You get this thing. So here, if you take this angle of incidence is I. This is the angle of refraction. This guy will be I and this will be 90 minus R. So here, the time taken for the light for BB dash and AA dash is equal because it's the same light ray. Now, if you consider the triangle ABB dash, sin I will be the opposite side, which is BB dash by AB dash. And the BB dash is nothing but the speed of light C by mu1 into time. Similarly, if you take the triangle AA dash B dash, cos 90 minus R is AA dash by AB dash. And AA dash is nothing but speed of light in the medium c by 2 into time. If you divide these two, you will get sin I. Cos 90 minus r is sin r. This becomes BB dash by AA dash. So this will be mu2 by mu1. Cross multiply, mu1 sin I is equal to mu2 sin r. That's your Snell's law. There. I proved Snell's law. So Snell's law just didn't come out of thin air. We actually proved it. And all that we used is one simple concept that the light ray travels different speeds in different mediums. Is this making sense, everyone? Look at the derivation. It's a pretty neat one. Meaning they can just give this picture with the distance and then ask you refractive index. So Snell's law just didn't come out of thin air. We can actually prove it theoretically. I can actually use the Fermat principle also using maximum minimum and prove it. But this is more intuitive. Is the proof making sense, everyone? How is angle A dash B 90? See, normally this thing, right, is called a wavefront. So when the light is traveling here, it's a perpendicular basically. So from B, you drop a perpendicular onto this light ray. We'll see later on in wave optics. Basically, in the direction of the light ray, you get a wavefront which is always perpendicular, just like equipotential surfaces and field. Clear with this? No. So let's say this is mu1, this is mu2. Let's say you're going from rarer to denser. So if a light ray goes from rarer to denser, what happens? It comes towards the normal. Let's say if a light ray goes from denser to rarer, the light ray goes away from the normal. Now, if you keep on increasing the angle of I at a particular angle, this will be theta critical, the light ray becomes horizontal. So mu1 sine theta critical is mu2 sine 90. So from here we get sine theta critical is equal to mu2 by mu1. So theta critical is your critical angle. Now, if you exceed this angle, if your angle of incidence becomes greater than theta critical, the light ray simply bounces off like a mirror. There'll be no refracted ray. The light won't even enter the other medium. This phenomena is called total internal reflection, TIR. I'm sure you studied in school till here. Clear with this? Look at this thing. So that you created a light beam by putting a small hole in a cardboard. So that's the protractor there. So here basically the refraction is happening where? On the flat surface, isn't it? The light ray is going from glass to the air. And look at here, when the angle is, this is almost close to 20 degrees. Your angle is close to around 33, 32 degrees. R is greater than I. This is 30. You're getting close to 45. You can see almost now, there's already a small reflected ray. Something close to around 40, 42 degrees, gone. You can clearly see there is nothing on the other side, see, except some dispersion. There is no refracted ray on the other side, completely dark. So this is your critical angle, say just slightly greater than critical angle. Now, if you continue to increase the angle, that interface will act like a mirror. Nothing will enter that side. Yeah, this guy is taking it almost that flattish. Later doesn't go that side. There, that's how it looks. There's another video there. And there's the TIR there. Music is too much, right? Where is this? I wanted to show. Yeah, this one. There, this is the pictures which I showed you. So they're using a concave mirror of 10 centimeter focal length. Mirror holder screen. Able to hear the audio, right? Just a music there anyways. There, they marked it on a paper, pole, focus, and center. So case 1, object is very far. So they kept it a little far. You can see the small dot on the screen. That is a candle flame ka image. There you can see more clearly now in the dark. Can you see it's an inverted candle, the flame. So the image forms at the focus, inverted and diminished. So real, inverted and diminished. Object beyond center. So they kept it just outside the center. There you can see the inverted candle. So basically the object is the flame. The object is beyond center. Image is real, inverted and diminished. Object at center, they kept both at the same place. There, same size, inverted. Object between center and focus. You'll get a magnified image now. There you can see the flame is bigger. Object at focus. You get a large image. There you can see in dark, pretty large flame. Object between pole and focus. Nothing there. Except some reflected light. So where is the image? It's virtual. It is inside the mirror. Direct, magnified, and virtual. That's a bit about it. I'll post the video in the group anyways, you can check it out. I wrote I greater than R. Yeah, this is R greater than I. Clear with this? So that is your TIR and refraction. Now here there is one more thing here. When you say denser and rarer, again, this is a concept from waves. How do you know a medium is denser or rarer? It depends on what. Again, remember, denser is nothing has to do with your density rho. It's not your mass density. So a medium is said to be optically denser if the speed of the wave is less. So if a wave is traveling slower, then we say the medium is denser. Similarly, the object is said to be rarer if the speed of the wave is more. Now, this is important. So let's say we have air here, we have water here, and let's say you're sending a light beam. Now you tell me, when you send a light beam, light travels faster where? Air or water? Light travels faster in air, so air becomes rarer, water becomes denser. So whenever a light beam goes from air to water, it goes from rarer to denser, it gets closer to the normal. Same thing, suppose, let's say you're sending a sound wave from air to water. Sound travels faster where? Sound travels faster in water. So water becomes rarer, air becomes denser. So the whole idea about what is rarer and what are denser depends on the wave. So if you send a wave here, sound wave, it actually goes away from the normal. Is that clear, everyone? So even sound obeys law of refraction. But what is rarer and denser totally depends on what you're using. So this is the kind of question they can ask in the exam. They'll simply say a sound wave is going from air to water. What will happen? Will it go towards the normal, away from the normal? We remember like what? Okay, air, water, air is rarer, water is denser. You'll think towards normal. So the idea, right? The density has nothing to do with your denser and rarer. It is always the speed of the wave. Clear, everyone? That's one theoretical thing. So be careful with that. Let's see a few questions on this. This is a standard question. Definitely remember this. Let's say mu1, mu2, mu1 is greater than mu2. You're going from denser to rarer. So if you send a light ray here, this is I. So plot the deviation versus I graph. Plot delta versus I. So for different angles of incidence, you get different deviations. Plot the graph. Let's get this. This is a good one. Think for a minute. Listen, there are two cases in this. If your angle is less than theta critical, the light ray will be something like this. So this is supposed to go straight. This will be your deviation. So delta will be R minus I. And this thing doesn't look good because mu1 sin I is equal to mu2 sin R. So R will be sine inverse mu1 by mu2 sin I. Now, if the angle is greater than theta critical, now you'll have a TIR. This light ray simply bounces off. If this is I, this is I, this angle will be delta. So you will get delta is nothing but 180 minus 2i. If you actually see this carefully, delta minus 2i plus 180, this is a straight line. So this graph will have two parts. You should definitely remember the graph. So initially the graph will be a curve, something like this, increasing till theta critical. At theta critical, suddenly there will be a discontinuity, increases and then decreases. Why will there be an increase in discontinuity? Think of it like this. Up to critical angle, so when you're giving exactly critical angle, this is how the light ray goes. If I increase the angle by 0.1 degree, suddenly it becomes like this, isn't it? So isn't there a sudden jump in deviation? So just by increasing a little 0.1, suddenly this whole thing just turned a lot of angle. So the deviation will suddenly bump up and then decrease linearly. That is how the graph looks. The graph is more important. Clear with the graph, everyone? Next one. We have a glass sphere. Mu is equal to √3, mu is equal to 1 outside. This is your center. You are sending a light ray like this at an angle 60 degrees. Draw the path and find the deviation. See. Right, Ishana. See. So if you apply the Snell's law here, we will get outside is 1. Sine 60 is √3 into sine r. R is 30 degrees. Now remember, this will be the normal. This will be 30 degrees. This will be the normal here. And you can see this is an isosceles triangle. This is R, that is R. So if that is 30, this is also 30, this is 120, and this is 60. Again, from Snell's law, this angle will be 60. This is 60, this is 60. Matlab this line and this line are parallel. So the light ray comes out horizontally. So your final light ray is like this. Your initial light ray is like this. This angle is 60. That means this light ray got deviated by an angle 60 degrees clockwise. Is that clear, everyone? Any doubts on this? Yeah, I think most of you did get 60. There will be no TIR. Why there will be TIR? Next one. This is another standard model. So let's say we have a swimming pool of depth D, refractive index mu. You kept a bulb at the bottom of the lake, bottom of the pool. Now, technically, we expect the whole pool to be illuminated, but that doesn't happen. If you're standing on the side of the pool and if you look at this pool ka surface, an observer sees a patch of light on the surface. You don't see the whole surface illuminated, only a part of the surface is illuminated with light. So you need to ask yourself, why is that happening? So find the area of the light, find the area of the light patch. If P is the power of the bulb, find the power escaping the water. So how much power is coming out of the liquid? If the bulb ka power is P, so how much intensity of light is coming out of the pool? Let's get this. So what is happening here? Why is there only a light patch and not the whole surface illuminated? The thing is, the light ray which goes straight, this is fine, but as the light rays start going at an angles, you will notice at a particular point the angle becomes critical angle, isn't it? Once the angle becomes theta critical, what will happen after this? Every light ray that hits the surface will bounce off inside. So light rays incident at an angle greater than theta critical bounce off inside. That means all light rays after theta critical will not go outside. So this angle will be theta critical. This will be that light patch. So it will happen in 3-dimensional. So you'll get a cone of light like this. This will be the radius of the light patch. This will be the D. So tan theta critical is R by D. Area will be pi R square. Sin theta critical is 1 by mu. So from sin theta, how to get tan theta? 1, this is mu. This is root over mu square minus 1. So tan theta is 1 by root over mu square minus 1. You substitute that, you get the answer. Now, how do you get the power escaping? This we have done already. This is the third time. Fourth time technically. Think of like this. Forget about the water. If you put the bulb at the center of this thing, right? So indirectly, isn't this what is happening? So this light patch which is there, so every light ray that is supposed to go out of this surface, just like flux, the flux passing through this area must be equal to the flux passing through the disk. Agreed? So that means the power passing through this shaded green part must be equal to the power passing through the disk. You guys remember the area? Surface area of a part of a sphere. Shaded area must be equal to power through the disk. How much is that area? So the shaded area is 2 pi r square 1 minus cos theta critical. Hope you remember that. So you're done. So power escaping will be total power P by total surface area 4 pi r square into the area of this part, which is 2 pi r square 1 minus cos theta critical, which is P by 2 1 minus cos theta critical. This much power is escaping out of the liquid surface. Is this making sense, everyone? So every light ray that passes through the disk would also pass through the green surface, isn't it? If there is no water, so the power must be same. This is kind of like the flux curve question. So if you kept a charge Q in the center and if I ask you find the flux passing through the disk, that is same as the flux passing through that green area. All clear with this? And if you look at this, this also tells you something like, if there is a fish living in the water, how will the world of a fish look like? So when the sun is rising, the light rays will come almost parallel. So this will enter at an angle theta critical, reverse. So the fish will think sun is rising here. Similarly, when the sun is setting, the light rays again will enter the fish at theta critical. The fish will think sun is setting here. So in a fish ka world, the sun starts here and sun ends here. So if there's a fish living in the water, for the fish, the edges of the world are compressed. Did you ever heard this term fish lens? In cameras and all, you have ultra wide lens and fish lens. So if you have a fish lens, right, this is what happens. The edges of the images get, compressed. So if there's a fish living in the water, this is how the world of a fish looks like. It thinks the whole world is compressed into a part. It's not 180 degrees. Clear with this? There, so that's a little bit on refraction there. So next class when we catch up, we'll continue from here. We'll do more refraction problems. We will do something called apparent depth and all, quite important stuff. So next class will be based on all that thing. And then if time permits, we will see little refraction and reduction also. There, so we almost done 21 questions. So start doing it. And I hope everyone has finished your current electricity or whatever work that you're doing, at least one material. There's a test online on current electricity. It is 60 questions, 2 hours. So prepare well, give it. It's a good practice, right? Quite an important chapter. Like it has a pretty good weightage, current electricity. Okay, with that we'll wrap up for the day. I'll see you guys again on Monday at 8:30.